there's N. And then, I think you guys, when you, especially at the beginning, when you guys are learning about how to write nice proofs, it's a little too easy to say, oh, it's obvious, or just do it like we did before or something. So I'm going to spell this out in a little bit of a gruesome detail. So this gives a tricoloring because I'll leave out a little bit more and more of the gruesome details as we go through. But I guess the first is, if at least two colors were used in D1, we didn't reduce the number of colors, right, for D2. We didn't reduce, we didn't throw away any colors, right? Like if there was more than one color in here and somehow we, like say, we saw 3 colors in this region and then we colored it somehow differently so there weren't 3, then we might worry we might have messed up the tricoloring. But we didn't reduce the number of colors for D2. So the first condition should still hold, right? We didn't use less colors. So the second one is you have to check the crossings, right? The crossing condition. The crossings not in the modified area satisfy the tricoloring condition. So the crossings not in the modified area satisfy the tricoloring condition on crossings right, and the new crossing we created clearly satisfies the condition, right? The new crossing we created clearly satisfies that condition, right? All the same color. It's all the same color. Right, so I guess we have to, technically we only went from here to here, right? Like if we were doing type 1 moves, we could be doing a type 1 move that removes a little loop like that and straightens it out. So we have to check that too, right? We have to always check both ways in this proof. Seems very laborious, but I mean, at the end of it is to ultimately be like, we're convinced this was true, right? Don't just make stuff up. There's actually a pretty, if you look at internet shirts, there's I guess a pretty well known one that says I make stuff up.
Internet shirts?
Yeah, like.
Hey, I'm with you. That's where you got the Dr. Drew shirt.
Sure, but that's not the point here. All right, so now suppose it is D2 that is tricolored, and we want to tricolor color D1. So D1 and D2 is still the same as before. Now we're sort of going backward. Now we want to go from here to the other way. Okay, so here. Okay, so I guess the thing here is not as hard as you might think, because you might be like, oh, there's a strand coming in, and then there's another strand coming out. Do they need to be colored the same? Maybe they're colored differently, right? Like if this is colored red, maybe this is like colored blue going out. That happens. No, EFAT says no. It's so ridiculous, right? It's like funny to consider that possibility. So you guys are laughing. Epad says no, why not?
Because like if it's single crossing, then it has to be the same color.
Right, so if you look here, you can't have only two colors appear at this crossing. This little curly thing is a little funny because if you look at this strand, it shows up sort of twice at the same crossing. So whatever color you pick for that, this part's colored the same, and then here's the other part, but that would violate the tricoloring condition because it has to be all the same or all different, right? So you have to have three colors appear, one color. You can't have two colors appear. So you realize, oh, this must be the same color. So if this is colored in, then as you go around here, this must be colored in because of the tricoloring condition. We're assuming this is tricolored. So this has to be in, and phew, that works, right? Because if they're both colored in, when we do to move the strings out here, the part that connects out here, right, we know it's colored in. And we know this is colored in because we only do stuff in here. So we can just leave this colored in. So it all works out. So it's still, you know, it seemed like we're in trouble, but we weren't. So let me just write this down. If the part, let's see, if the modified part of D2
I accidentally paused it. Is it for changing?
has one color, I guess somehow I wrote it a little convoluted here, has one color, we keep that color. And we have a tricoloring. And here I guess no need to be too, I mean there's a careful line we have to plot. I mean we can always just keep saying is there at least, you know, two colors, stuff like that, but let's just say here, and we have a tricoloring for the same reasons as before. So there's a little bit of style that you don't want to always spell it out and bore your audience. Okay, but I guess as we said, it's impossible to have more than one color in the modified area. So, but it is impossible to use more than one color in the modified part without violating the tricoloring condition. Or I guess we could say we have to use possibly use more than one color in the modified part because we would have to use two because we would have to use two colors, right, which violates the tricoloring condition, the second tricoloring condition. So, which violates the tricoloring, that's the second tricoloring condition. Okay, so all right. Is everyone happy we disposed of the type 1 move? Everyone's satisfied. Someone feels a little touch of victory here. We're probably 10% of the way through here. But okay, now let's consider type 2 move. Now consider a type 2 move. I guess let's call this one that looks like this inside this region. Let's call that D1. Let's call it thing here that where you put one strand over the other like that. Let's call that D2. Now, I guess the thing to notice here is, say we go from D1